Good afternoon students, that is EC 8553 Unit 4 Finite Word Length Effect. Here representation of numbers. The fundamental operation in digital filters are multiplication and addition. When these operations are performed in a digital system, the input data as well as the product and sum have to be represented in a finite word length, which depends on the size of the register used to store the data. Okay. So, now for the digital computation, the input and output data are quantized by rounding and truncation. It is followed here to convert them to finite word size. That is a difference, right? This creates an error in the output or create oscillations in the output. Okay, that is the major role. That is oscillation in the output. These effects due to finite precision representation of the number in a digital system are called finite word length. So, finally, there is oscillation is followed. Here list some of the finite word length effect in digital filters. Errors due to quantization of input data, errors due to the quantization of filter coefficient, errors due to the quantization of rounding the product in multiplications, error due to overflow in addition, then finally limit cycles. Then fixed point representation of numbers. In fixed point arithmetic, the position of the binary point is fixed. The bit to the right represents the fractional part of the number and those to the left represents the integer part. So, example 101.1100 means 101 is the integer point. After the fractional part, after the point we can say it as a fractional part, that is 11001. Types of fixed point arithmetic: sign magnitude, 1's complement and 2's complement. Then sign magnitude form. For sign magnitude representation, the MSB digit is used to represent the sign. If MSB equal to 0, the number is positive. MSB equal to 1, number is negative. So, 0.625, that is 0101 of 2, minus means we can put 1.101, that is the difference here. 1's complement form, the positive number is represented as in the sign magnitude form. To obtain the negative of the positive number, complement all the bits of the positive number. Okay, 0.625, 0101, likewise same, minus 0.625 means that is 1.010 here, right? Then 2's complement form, see, in 2's complement form, the positive number is represented as in the sign magnitude. To obtain the negative of the positive number, complement all the bits of the positive number and add 1 to the LSB. So, for 0.625, 0.101, here the minus means 1.0112, right. Then floating point number is represented as x equal to m into r power x mantissa. That is a mantissa form, where m is the mantissa, 0.5 less than m less than 1, r is the radix, x is the exponent, e is the exponent. If r equal to 2 means directly apply the formula and we get the result like that. Then floating point addition and multiplication also the same. Let x1 equal to m1 into 2 power e1 and x2 equal to m1 into 2 power e1. Then floating point addition means x1 plus x2, then add the 2 term and finally we get the result. Now, we see express the function 7 by 8 and minus 7 by 8 in sign magnitude form. For positive number 7 by 8 of 10, that is equal to, we get the result 0.875. Then if we consider, so see the here the calculation is there, 0.785 into 2, we get the result 1.750. So, at a time we have to take only integer part 1. Then from the fractional part we have to again multiply it, 0.750 into 2, we get 1.500, we get the integer point 1. Then after that 0.500 again it is multiplied by 2, we get 1.000, we get the result 1. Then 000 is multiplied by 2, we get the result 0. So, now we take the value 0.1110, okay, 0.1110. So, now we have the negative number minus 7 by 8, that is equal to minus 0.785, no. So, at a time we have to put it as a 1, that is a negative number, 1 as it is an integer part, we have the value 1. For 1.1110 of 2, only changes MSB bit to one of the negative number. So, likewise we express the number plus 7 and the minus 7. in for 1 complement form. So, plus 7 0 111 of 2, here m must be 0 indicate the positive sign. For the negative sign means here the minus 7 1 000 of 2, that is a difference is there, no, here the available 0 111 for the negative number 1 000. So, that is all. Express the plus 12 and minus 12 is 1's complement form. For positive MSP should be 0, so representing in 5 bits. Okay. So, 0 11 00, then the minus 12 means we have to calculate the number 1, that is a 0011. Then represents minus 9. Likewise, we have the some several formulas available. Here the comparison of fixed point and the floating point. Fast operation for the fixed point, here the left side is the fixed point and right side is the floating point. Fast operation and slow operation, relatively economical, here the more expensive because of costly hardware. Here the fixed point small dynamic range, here the increased dynamic range. Here the round of errors occurs only for multiplication, here the round of errors occur for both multiplication and addition. Then addition leads to overflow, then overflow is a rate phenomena. Then used in fixed point used in real time application, here the floating point used for non-real time application. Here the one of the main role is a truncation and a rounding. In fixed point or floating point arithmetic, the size of the result of an operation may be exceeding the size of the binary used in the number system. And truncation is the one of the quantization process. In such case, the lower order bit has to be eliminated in order to store the result. Two methods of eliminating these lower order bits are truncation and rounding. This process also called as the quantization via truncation and rounding. So, what is an truncation? Truncation is the process of reducing the size of the binary number by discarding all bits less significant than the least significant. In the truncation of binary number of b bits, all the less significant bits beyond the b bits are discussed. Truncation error, the fixed point number system, there are 3 different type of number representation. The effect of truncation on positive numbers are same in all the 3 representations. Okay. So, x equal to original value of the number, so q1 of x minus x. Okay. At a time we have to calculate the truncation. The error due to truncation of negative numbers depends on the type of representation of the number. The case 1 plus positive number, the unquantized positive number in the range q1 of x equal to 1 into 2 power minus b. Case 2 is the negative number, means q1 of x equal to minus 1 star of 2 minus b. Then the error range calculation. Then the 2's complement representation, the minimum maximum error, and for the error range is also available. This is the second calculation. Then summary of fixed point numbers, this is the summary, there is a tabulation form. Then for the positive number, minus 2b2 e power et, then less than or equal to 0. Then sign magnitude negative numbers means we have the formula. Then 1's complement is the same, then the 2's complement minus 2 power minus b, then less than et less than 0. Okay, thank you students.